the 405. Oh, wait a minute, we have... Never mind. Yeah, we have our friends. That's true. All right, so give a warm round of applause here to Jimmy. So.
My talk's on, this is all just Android SMS sending codings. Not really. We're actually seeing a whole bunch of real advances in what we see in Android malware. Let's actually take a look at the numbers real quick. So right now what we're looking at is not just malware, it's also what we call potentially unwanted programs. These are your spywares, your hack tools, your various things you may or may not want on your phone. Things maybe your enterprise is on your users' phones. Similar things like that. The trade-off now is between about 50% malware and 50% things you may not want on there. But the actual breakdown of malware is like kind of interesting. Even though SMS tokens still make a small dent, or a smaller than they did before. Here we go, about 18%. The largest segment still is basically sending information, stealing information from users, backdoors, botnets, malware that uses root exploits. So basically, if you rooted your phone, you could be in more danger. Maybe, maybe not. I'll actually cover a few examples for that. But it's really now a smaller portion of people doing SMS sending trojans, which is a good thing, I think. I mean, it's like that's the easiest possible thing one could do. Okay. You install an app on someone's phone and send out SMS messages to primary numbers. Really simple, really easy, really annoying. And it's good that I'm glad to see them disappearing. Alright, so let's look at actual attacker tricks. Tricks that attackers are using now to make their malware much more interesting, much more useful, much more, I guess, evasion of security in general. This is actually where it gets more fun for us, for me and my team as malware analysts. What we're looking at is actually a much more, it's more complicated. I mean, they start out simple with like simple obfuscation, encryption, and whatnot. Like, okay, hiding like the SMS number messages in it. Simple stuff. We don't see this anymore because there's not a lot of money in premium rate SMSs, and it's easier for the carriers to shut down those numbers quickly. So you can't profit as much. We're seeing a lot more in, I guess you could call it the botnet region, where I think I did talk last time on profit-taking malware. Basically, you write a botnet and you use, you infect, say, a million devices, maybe in China, and you say, okay, I've got all these devices, I've got to worry about getting $1 from each user, and that's about 1 million users. Great, makes a lot of money, but I've also got to defend against my competitors. Not us in security. Actual other competitors, people who are in other criminal gangs who are saying, okay, we have primeware, we have trojans, we have our own botnets. We can either build our own network or just steal our competitors' networks. And how do you keep your competitor from taking your network? Well, you start using advanced encryption, you start using real encryption algorithms, something like DES, something like AES, and you encrypt your traffic. You're not worried so much about people like me and my team. Going off here yourself, because at that point it doesn't matter. What you're really worried about is someone taking over an existing network and grouping up all your bots. It's kind of what's going on, so you also to encrypt your exploits you can use. That part's for us, that's for me and my team. So it makes it harder for us to detect, slightly harder, not a lot harder, slightly harder. They really aren't worried about us. We don't dig into their profits as much, because they can quickly and disappear. They don't really care. It's the competitors taking over their people. Something a little bit more interesting than that, though, is fraudulent apps. These are apps that are like actually, they're not the real applications. This is not the same thing as, say, putting code into an app, like a virus would infect a legitimate application, or the bad guys putting their code into a legitimate application. This is just an app that pretends to be another one entirely. So it has just enough of the trappings to look like maybe a fake token generator, or in the case of like the fake token, or one-click fraud where it's like, okay, it's designed just to get your money out of somebody, so it pretends to be like a adult entertainment application. You'll notice kind of like all of these classes in red that are in both these files. These are majority are just malicious functions. There's no actual legitimate app there. in contrast to the injected code. This injected code, once again, is something like Droid Beam, where they infected over 30 different applications, real applications that function as real, that actually do something. They could be games, they could be something else. These are things that don't do anything else except rip you off and just put the trappings and pictures and word to tell you it's real. And it's nothing close to that. It's either total fake apps. Case in point, Android Fake Token, which pretends to be like basically an app for a number of different banks. Those security token ones, like an RSA key fob or the RSA digital card. The numbers keep changing every so often, same kind of thing like this. So it's an app you install on your phone, and you type in your password. And then when you type in your password, you get a new minute long, I think is the lifespan of that code. And then you type in username, your password, and that code, and you're logged in. Excellent, right? This app doesn't do that. It just does enough to get you into your password, and then it forwards that to the attacker. So the attacker can take your username, password, and so on, and log in for you. Lovely thing. Totally love that. I think it's exactly what's in the code. Yeah, right. I don't actually remember. Point is, there's no actual real code. If you go back to the previous one, you will notice that all those classes are there just to implement this functionality. Not actually giving you a code, not implementing their pseudo-random number generator to give you whatever the algorithm they were using for the original app. Not that at all. It's completely fake. It's a total fraud. Then we got something like one-click fraud, which is something totally different. Claims to be like, I guess, an app that'll send you to an adult entertainment site, and at the same time, it's trying to blackmail you by saying, "Give me $5." I think it's every 5 minutes. Every 5 minutes, it's asking you to say, "Okay, pay up," and it doesn't actually check to see if you paid up. It just lets you go and pay them. It takes you, click the button, it takes you to the website, and you just keep paying them because you're either embarrassed or nervous or worried about being caught or whatever the heck it is. One of those, and it's basically an app that does nothing except have the image that it's probably good for adult entertainment, when it is just very good for making money for the attacker, which is successful for them. A little bit more about that. It also sends further information from the user outwards. Things that can identify your phone, your IMEI, your Monzy, your Google account information, which I'm not 100% yet how you exploit that, just having that information out there. We haven't seen that in action. We've seen a lot of things in a lot of the botnets. We've seen attacks where you have a botnet, client that infects a phone, and then it starts collecting individual identifiers, like your system serial numbers, like your IMEI, your Monzy, your Google, your Android unique identifiers, things like that, or your account name. But I'm thinking mainly that's just so they can verify that these are all individual installations and not just a way to steal your information. We haven't really seen a lot of identity theft as such from mobile apps. Mostly it's all about getting unique installs, sort of like what you got on the spyware side of the PC, unique installs making money for the distributor. Something a little more interesting, that was fraud. Once again, fake apps that don't have any real functionality. Now let's look at what's actually more interesting, code injection. I mentioned Droid Beam earlier. That was one that got into the Android App Store, when it was still the App Store, not the Play Market or whatever they're calling it today. Basically, that was a bunch of clean apps that had code injected to it. This is the same case with this, it's an Iranian recipe app. So if you want to make some cook some Iranian food and you want to look at some recipes and you have some pictures and whatnot, you download this app. It's a real legitimate application. I haven't actually seen a legitimate application, but it's real and there's a purpose for it. It's very useful. It's a cooking app. Except the version that's getting out there is this one that's been infected by I believe manually infected, because I actually did a talk on what are the file infecting viruses on Android, how are easy to pull off. And it's not difficult to pull off automatic infection of apps, but we're not seeing evidence of that happening. I mean, instead of seeing 30 apps or 40 apps infected, we'd be seeing thousands daily almost, because it's that easily basically infected a bunch of apps. In this case, this is a nice application. It does what it says it does, but it has code to do a little bit more. If you might have heard of the name Mogapa, or its second variant, Cap Stamper or Stamper. This is an application that basically, it's a real virus. It actually infects the file. It doesn't infect other application files. It doesn't infect an APK, an Android APK or an Android program. It doesn't go into those. Because those are the more difficult. You have to solve a bunch of problems like signing the app, decompiling the code, or disassembling and backsmalling the code into download bytecode, modifying it, and then repacking everything. A bunch of steps no one's really doing, and very few do it. I mean, there's privacy inspectors allowed to do it on your own, but no one's doing that. Instead, this is a traditional overriding file inspector. It takes your, it searches for all of the, what do we call them? All of your photos on your SD card, and it basically adds a picture of the Ayatollah Khomeini, previous deceased Ayatollah Khomeini, to each of your photos. So it scans everything on the disk, finds all the JPEGs, and says, boom, let's stamp that picture on there. So it's basically, you end up with the Ayatollah Khomeini photobombing every one of your pictures. It's like, awesome, right? Not for me, not for you. I don't think anybody would be like, even if you're a fan, and like, no, you ruined all my pictures. What the, you know? So it's actually the real code injection, and you took the difference. Like the previous picture of the fraud, there was majority red, and red classes were the malicious part. In this case, we're looking at basically majority is clean code, and then blue, and in like red, it's like a handful. It's like basically 3 or 4 classes that do the job of injecting the single, what do you call it, photo into the other photos, combining photos with you, or what they call it in this case, stamping. And it really does stamp it. The problem with this thing is it's buggy. It doesn't really, like traditional viruses on DOS or Windows or whatever, file infecting viruses, when you infect a file, and your file infecting virus, you say, okay, I don't want to infect the file over and over and over and over again because I'll just keep getting bigger and bigger and bigger and bigger and bigger. And you're going to start noticing that. Instead of a small file, I'm not going to be a large file. That, if you do it for all the files on disk, you get noticed. In this case, you're doing it to photos. And what they're doing is, how they solve it on, or how they solve it, like, I don't know, how many years we're talking about, 15, 20 years? How they solved it back in the days of DOS or the file infected virus was you usually change a value in the file header, or you put a marker at the end of the file saying, hey, I've infected this file, why am I wasting my time with it? It's gonna do, and the author of this piece of malware did all of that except that one little check that's so common, that's been done for 20 years, it's a best practice, and if you're writing a virus, just in case you ever decide to do that, it makes it easy for us as malware researchers to detect it, because it works good for the writer, so they don't infect files. And it works good for us because we can mark all files are infected by something. It works both ways. It's a flag, right? He didn't leave that, or he or she or whoever wrote it didn't leave that flag in there. So they keep infecting things. It's basically, this code here is the injecting code, the stamper code, and all it does is they get a picture right over there, this little picture over here, and puts it like in the lower left corner of every one of your pictures. Very nice. But since it doesn't check it, it'll put it into your picture. And so you have a picture of that, and then your original photo stamped on top of each other, and then from there it adds it one more time again, and then one more time, because then it actually continues. There's no actually any limit until you run out of space on your SD card, which is really kind of annoying. I have all these pictures of the iPhone. Yeah, it's not just him. What you end up with is a deteriorating version of the original picture, because a new version, a fresh version of this picture gets stamped on the photo, and then recompress, and that starts to deteriorate the other photo. And an example of this would be this nice Creative Commons licensed picture of Obama speaking, and then you have the Ayatollah one time, and then a second time. You might notice in the background it's starting to get lighter and lighter and lighter, and there's a little more static and a little more, it's getting a little more grainy and whatnot. And then again, and it keeps going and going. If I let it keep going in the emulator, it would have turned into mush at some point, but he would still be there, haunting your photos. So what is this? A little wacky. That's file infection. That's a nice trick. It's really workable for people. But we've got more things that they can do. More things that Android malware can do. But they're doing more than just, once again, sending SMS. They're saying, okay, let's record audio. Why would you record audio? Audio on your phone is either your touch tones when you type in your credit card number, your social security number, something like that, when you type it in. It's also audio of your phone calls, your private calls. Maybe you got trade secrets. Maybe you have, I don't know, maybe you're having an affair with somebody. You don't want any of this information to get out there. You really don't want them recording your calls. So where have we actually seen this in real life? We've seen them in academic projects. This one in particular is TouchLogger. It was designed really interestingly. You had basically two parts. There was one part was the thing that the part that monitored all your calls for connected to one of those IVRs, interactive voice response menu-driven system. Press 1 for this, press 2 for that. Type in your credit card number and then pound, those kind of menus. They have the academic team had a list of, or a database of a good number of various menu-driven systems like that. So you would be able to target small segments of audio where they knew you were typing your credit card number, or they knew you were typing an account number, and they would just grab that small, maybe 10 seconds worth of audio, and process that small segment and convert that into digits. And in the second application would take those converted digits, those recognized digits, and send them back out to the attacker. So instead of sending an entire audio file of, I don't know, maybe half a meg to a meg of live audio, whatever, you've basically done, I guess, audio recognition on that file and turned it into digits, and then sent 16 bytes out there, or whatever, Unicode out to the attacker, back over the internet. Very neat concept, done in the beginning of the year of January. We didn't see this actually take place in real malware until later in the year. People actually trying something similar, trying a little bit better, actually recording audio, actually putting some effort in it. Never as complex as that, where they had a database of the actual numbers and whatnot, in this Samcomer, what do you call it, application, or set of applications. Nothing ever that complex, but they were doing recording, which is actually more common in spyware and had been for quite some time. Because spyware is there so you can record your calls, record your significant other's calls, spy on your children. Oh, I'm sorry, track your children so you know they're safe. Yes, spyware. It was very common because that's what people were looking to do. That we're seeing in malware. We're seeing some in a couple places. Basically, two big ones were Nickify, which was I guess used by a few other companies. Well, one company has a demo to show that you can get onto a system and then automatically install on an Android phone. So-called drive-by downloads. Drive-by downloads, not drive-by installs. Like on your PC, you have a drive-by install where you go to a website and there's a vulnerability, and oh my god, automatically something gets installed on your phone or on your PC and you're infected. Doesn't quite work that way on Android. On an Android phone, what really happens when you visit a site that has like a URL that is an APK, it will get downloaded automatically, and you could theoretically install it. But it doesn't install automatically as such. I mean, it's there, but it won't run. So it's not an immediate drive-by install. Very nice, very neat concept. You click on it and it'll install, but it doesn't do it by itself. Point is, both of these two applications, Nickify and Golden Eagle, instead of going that advanced route of taking audio and processing it on device and then shipping out the relevant information back to the attacker, which is efficient, very nice, neat concept, straight out of academia. So I'm like, why aren't the bad guys doing so much research and development? I mean, it seems like everyone in the universities is like actually trying hard. Saying, okay, let's see how to make this interesting. We're not just getting bored and like, taking an audio file and like these two lazy developers and shipping that back to the customer. I mean, like we have unlimited data. Not everyone has that anymore. If you're on Verizon or something or another provider, you're not going to have unlimited data anymore. So it's like, that's constant. Yeah, the tap taken by Soundcomer, where they send out the relevant information, much better deal. Really good though if you're trying to go after actual conversations like trade secrets, like stock tips, stuff like that, credit card numbers, things like that. Well, less of the credit card numbers and the pins, but actual information and I guess your murder conspiracies, things like that. Just ship them off to somebody that's what you want audio. And that took till like the end of the year to see anything from that from anybody. Kind of neat, but it's not really taking off as much as we expected. I mean, nothing close to this app here. Nothing at all. Much more, I guess, what would you call it? Not complicated, not simple. Simple, lazy. Lazy, I think is the term. Another trick is basically malware updates. Malware can update itself, or two different ways you can do this. One is being a fake update, pretending to be an update. And the other one is actually updating the mobile client, saying, okay, let's add more functionality. You don't need much for this. It's pretty simple to do. You just need like a simple permission install package. A nice, simple permission on Android. It's not so complicated like, okay, let me read all your contacts or something like that that you might be thinking of. Installing works. Maybe you tell the user, this is an installer program. That's happened to me before where I tagged, once early in my career, I tagged an installer program as malware because Basically, what does an installer program do? It has access to system directories, and it installs files in system directories, and it drops files on disk, and it has internet access. You can see where one would make that kind of mistake, right? In the same manner, if you call yourself an installer on like Android, and like it's designed to be like an update, like a system update, you're very likely to install it on your system. The chance of it being a real update, very slim, because apparently it's hard to get an update nowadays. It's either over the air, and your repair might push one out, or they might not, depending on how their QA process works. So you end up with people going to third-party route and getting something updated and saying, okay, this is an update, maybe I should install that. Right, so the main way you get attacked though is that way of pretending to be a patch, like the latest update that's built pretend to be like an ice cream sandwich update for Android 4.0 on for your phone that's not supported by your carrier. So yeah, I would like to get it updated. I would like all the advanced features. Let me go install them. That happens occasionally, but you do get hit and you get infected, and it's the one way it does it. But those are the bad. That actually ties it back into, I guess, fake and fraud updates. The really interesting thing is that malware is also updating itself, adding more functionality. Basically, if you're in the case of having those botnet clients, so you've got an on-device, you may have used an exploit, you may have done something to get on there, but now you want to be able to do a little bit more. Maybe I want to send an SMS, maybe I want to do some search engine optimization, maybe some black hat SEO, like sending traffic over to a site to drive maybe a million users still on a site to make it interesting or make it more appealing to advertisers. Basically putting money in the pocket with black hat SEO. Makes it a little easier. Maybe I want to send some information out to the attacker again, more than I had before. Maybe not just the trackers like I mentioned before, like your individual unique identifiers. Maybe they want a little bit more. Maybe they want your financial data on your phone. So maybe you try to read your bank account information, things like that. Or maybe an account for like Amazon or something that can be tied to some other credentials. Or even better, we've seen before with John Overhyde and Charlie Miller, where they designed Android applications that could basically download new exploits from a website and then run them on the phone. It's just like running native code, native exploits to root your phone after the fact. So they have kind of a foothold, and then they totally take over your phone. That kind of thing. So yeah, well, why real malware updates? Because even the bad guys know they got to update their stuff. They can't just let it sit. No, okay, we got to fix that stuff. Oh, there's a bug. That means no money. In the same way, actually, how carriers think. If the phone can't make a phone call or you don't have data access, you're not making money from this user. Your revenue's gone down. Totally not worth it. And never visual, because you don't really want anyone to know you're updating. Or okay, the user says, oh wait, so much fake update is updated. You don't want that one at all. You don't want them to know that. You don't want them to worry about it. You don't want them to approve the updates. You just want them to install and go through with what they're doing. Those are the main things you've seen in like professional research. Malware research or malware authors. In the case of what we call academic research, we're seeing a lot more innovation. I mentioned earlier with Soundformer, innovation, people trying to do new things, like new attempts, because they've seen all the boring stuff and say, we got to stand out, we got to be a little bit more interesting. In the case of TapLogger, it builds off of, or it's related to work done previously, like there was an app called TouchLogger and another app called Accessory, where the app pretends, either comes in one part or two parts, and it records your sensor data, like your accelerometers, or those when you move your phone. It can tell where you touch the phone on your keypad to say, okay, what number you're typing or what letters you're typing. It's a very neat concept. The earlier work TouchLogger was like that, where it had a training portion that said, okay, type something in or whatever, and it will recognize how when you touch the phone, it would move a certain amount on the sensor. You could record like, that's a 1, that's a 2, that's a 3, something like that. That's what they used to do. It had to build an entire database based on that, and then it would take that data and then use that to analyze your keystrokes. And so basically record all your keystrokes with a high success rate. In the case of TapLogger, what they did was first put together a little icon program. This is all integrated in one program, which is an improvement over the previous TouchLogger. One program that does all of this. In one case, it records like keystrokes, it registers itself to monitor your keystrokes, which makes sense if you're playing an icon matching game. So they've learned something that's pretty common. It's known already that if you pretend to be something legitimate and you give someone a reason to do something, they'll do it. They're like, That does match his icon that happened to be in the position of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 and whatnot. And I'm like, okay, you're touching them in the right regions, and they match up perfectly. And you go back and forth. Very, very neat concept, and very successful, and it's kind of neat. I mean, people are improving upon what they did before and making it a little more interesting. It's a little bit more, I guess, a technical thing from their actual paper where they said there's a small segment where they're creating an app with the icons. You take the data, you process it, and then you say, okay, here's what how I recognize all of these results, and then the numbers picked in. Then we send them back to the attacker. Very nice concept, useful, but not directly targeted at any particular banking software or your Trojan. At best, it's there for the, what's it called? Keystroke identity? No, that's not it. The lock code on your phone. It's there for the lock code on your phone, so when you type in your lock code, it picks it up. It's actually looking now at rebooting exploits. Okay, what do you do when you're with your phone? Okay, you do it for a couple of reasons probably. One is to replace the firmware because the firmware your carrier provided isn't doing what you want to do, or it has a bunch of bloatware that you can't remove on your phone. Maybe in the case of Carrier IQ, where you have what's essentially carrier provided spyware on your phone, you want to remove that. You don't want that kind of access on your phone. You can't unless you remove that. You basically boot your phone and place a clean firmware on there. Why else do you do it? I guess to gain a little bit more access, for maybe you want to tether your phone or something along those lines. It's your phone. You should be able to do that, like your own PC. You don't say, okay, I have to get permission from Microsoft before I can change things on my computer. Not so much. People wouldn't really love doing that. They really don't love not having that kind of freedom. But it's also useful for an attacker. So now that you've given basically root access on your phone, anybody can take over if you don't take some precautions, like disabling like the binaries, how they get it in there, like the switch user binary. I mean, you take it out, you take a SU out, and you can do whatever you like. And I mean, then they can't just run their software. And once you root your phone, an attacker can come on or utilize if you haven't rooted your phone, utilize the exploit that's been released by the rooting community to come after you and change up what you're doing, or change up your phone, or take over your phone and add their own keylogs. Very nice concept, good for them, and then it's also partially because it puts the users at risk because the root vulnerabilities the underlying vulnerabilities aren't patched quickly because of carriers and manufacturers, and I guess Google also not being able to coordinate and get everything out there as soon as possible. So I mean, you have too many players, too many devices, too many ways of getting everything out there immediately. So it leaves a lot of holes. And it's a little difficult. It's too many fingers in the pot, too many chefs in the kitchen, too many whatever metaphor you want to use. And you end up with the same number of popular root exploits being used on particular versions of Android. Just kind of irritating, kind of annoying, but I mean, like in this case, you got the gingerbread exploit. We have 18 different variants, which are not that complicated. It's the same exploit, the slightly modified exploits. Really kind of annoying. It's like they might change maybe a string here and there, or move something around. We detect those. We detect other ones like the UDEV exploit, 26 variant. Minor changes, minor things, because attackers are a little bit lazy now. They're making money off of doing all the previous tricks, doing the fraudulent apps, doing the botnets, doing all of these techniques. So they don't spend any of the money and time and effort to come up with their own exploits. They don't need to. It's almost a similar concept with the iPhone, it's where it's so simple for them to just let it happen that way. Let them go that way and let the legitimate rooters and legitimate jailbreakers do all the hard work for them, and then they'll go after it and just take it and run it themselves. And once again, leverage the legitimate users need to secure their phone in one way or another, either secure it or gain freedom on their phone. Kind of irritating, but it happens. I guess the final real trick that we have on Android devices is the one that's been like the most effective one for them so far, for the attackers on an iPhone. It's the server-side polymorphism. Different from actual polymorphism like old-style file infectors where they would change every infection. Every time you infected a new application or whatnot, you would re-encrypt like a new key, or you modify your code a little bit when you infected another application. They're not doing that. They're just modifying the code or or in this case, modifying the APK file, like changing a few strings here and there, but not changing the text file, the internal actual Delphic bytecode, not changing any of that, they're just making minor changes in the names, in the Android manifest file, minor things. But they're different enough that if you just did a simple hash on the file, you'd miss them. I mean, right now what we do on the antivirus side is we get a large selection of samples from the server-side modified files. Basically, every time you go to the website, the server will send you a modified version. So it's cheaper on the server side to do it because it's a full power PC, making it a server-grade machine versus a tiny little phone. So it's much faster to do, and we'll do the modeling very quickly and send a new link to everybody who downloads. What we're doing when we collect all of these samples, I could say maybe 10, 20 samples, we see what the commonalities are, see what little they change, and we can write a detection for that specific variant, or not variant, specific family of malware that is just slightly modified. Nice trick on the part of the malware guys, and you catch a lot of guys who are just doing simple hashes, because they've got to have thousands of detections for each individual one, rather than like a common generic signature for the lazy malware authors. Very nice concept. We cracked those. So what do we actually run across? Something like Android Fake Installer, which is a fake app that doesn't actually install. It's another fraud app. Doesn't actually install anything, and it has a few other features. But mainly, we detect, I guess, what was it? About 25 different variants that we detect on that right now, which is kind of nice. They can change continuously all they want in that, they can do that, and we'll still pick them up. But it's very low effort on their part, very low investment on their part. Because they can just write a script one time, and we can get the malware done once, and then just keep passing out to as many people as they want. They just pass out the URL to whoever you like, and just keeps getting replaced. Neat concept. Okay, go back there. I guess that's lots of tricks, but right. I just saw something recently I heard about it from Shakacon. Two researchers, Charlie Miller and John Hyde, I mentioned earlier, they went after Android's bouncer security software. This is the software that Google uses to protect the Android market from bad apps like these. All of these apps here. So okay, go run in their security software, static analysis system, and figure out what your app is doing. If it's bad, we'll kick it out. Sounds great. That's better than what we think Apple is doing on the Android Apple market or in the App Store, where they're maybe doing static checks and static analysis, but they're not necessarily doing emulation or checking for various malicious software in general. It's a very hard problem to solve. You can't just run a program and say guarantee that this particular one is good, so it's bad. We can't necessarily tell, especially if the app itself knows it's being debugged or knows it's an emulator, which was kind of interesting. This is exactly what Oberheim and Miller did. They wrote an app that figured, hey, we're probably going to be emulated at some point by Android, and or run in a security system at some point. Basically, they were taking the same thing that malware authors do on the PC side, knowing that you're in a possible hostile environment your app is going into. So what do? You talk back to yourself. You send a connect back shell to your machine. Very nice concept. Very interesting. That tactic actually worked quite well. Miller wrote the app and it loaded into the Google's bouncer environment ecosystem, whatever you want to call it. And they found out a few details. They found out they were running in an emulator. They were running in an emulator that's the same as the one in the Android SDK. Exactly the same, but it also has a single username. It's like no matter how many times they ran their app, it was like, okay, it's the same username. It has a few image files that pretend to be a real thing. Thankfully, not an image of the Ayatollah Khomeini, but an image that I believe was Lady Gaga or something. These are details that aren't fully out yet. I would actually talk to Charlie and John about this, and they'll be sending out details eventually of what they're doing. They might be doing it at DEF CON, but at the moment there are no actual further details on what they're doing. But they were able to if you watch the video, they're able to look and see that this is what Google's doing. They're running it in an emulator, running it for about 5 minutes and seeing what's available, see what the app does. Does it steal information? Does it steal files? Does it steal contacts? I mean, is it doing anything connecting outwards? Actually, it may not have caught the connecting outwards, otherwise they would have been cut off. But they did get through there and they figured out what bouncer was kind of doing. So these, I guess the real point is, these are the good guys. Charlie Miller and John Oberheim are the good guys. They're on our side. They're helping to protect us from the bad guys in general by showing this is the kind of attacks that are possible. We should all be protected against them. It shows that Bouncer has a bit of a way to go. It's a good start, a very good start, but it's still a bit of a ways to go. And I think if you might have caught earlier, Google is very, very good at adapting to changes. So I mean, once they saw it, I'm sure they've improved what Bouncer can do, other than banning Charlie's and John's fake account. You know, and that's a good start too. I mean, anytime you see an app done by like Charlie Miller or John Wright, that you think could be theirs, block it. That's some good recommendation, you know, because you know they are good guys, yes, but they're going to embarrass you. You're going to make it look a little bad. Okay, I think I'm pretty much done with this portion. Thanks to the guys from the researchers behind TapLogger for providing background information and further the research going on. And does anyone have any questions about these, about the applications or tricks or anything about Android and malware in general? Yes?
Yeah, I've been told and I've read that you have to assume that you trust your service provider. Let's say you don't. Are there any defenses?
Okay, the question is, you're saying we got to be told that we should trust our service provider, our carrier, or whatever, the App Store or the Google Play Store. What if we don't trust our app store provider?
And not just that, I'm talking your connectivity carrier.
Okay, the carrier themselves, right?
Yeah, so are there any defenses that you could do that would get around an untrusted service carrier provider?
Okay, so in case we don't trust the carrier or what they're providing, is there a way to protect against that? Not really any general way of doing that. It's like assuming it's a bad actor. It's the same concept that Google has with their Bouncer thing. They can't necessarily protect themselves. What you can do is to take, I guess, reputational advice from basically an app review app, meaning an application that'll scan your apps and say, okay, we've seen this app before, and 1,000 other people say it's a good app. We provide something like that. Other people provide something like this. I think a few other vendors provide the same thing. Even the Google Store itself provides it with the reviews. You have some idea. Basically, you're in that situation where you can't trust what you're getting from either your carrier or from someone else, you would have to basically not be a first adopter. You would have to let other people step in before you to do it. Basically, trust the people that your friends have used or apps they've used, and apps that have really good reviews. I mean, you can't really decide just by there's no technical way.
Okay, so what about the firmware? Let's get a new version of Android when the update comes out from your carrier.
Okay.
Is there any way to cryptographically check that with everyone else's version?
Okay. How to cryptographically check an update, a new OS update from your vendor, from your carrier? Yeah. To see if it's different from what everyone else in the world is getting. Like maybe you've got a bad. No.
Okay.
Then I mean, there's no way. The carriers won't give you that kind of access necessarily. You can do it with the third party firmwares because they all publish checksums. It's kind of the whole open source technique where if you go into SourceForge or wherever or GitHub, you have the checksums for that. But there's no way for you to check it over the air download until you get it. So you kind of are in the boat of trusting. I mean, there's no way to do it just that way. You have to start basically cooking your own malware. Firmware. They're very similar sounding, but no. You're saying if someone's running malware, how do I know my stuff's safe? You basically build your own. That's the only real way of knowing. Same thing like if you wanted your own Linux distro, you would have to do your own to make sure it's secure. In this case, you'd have to pretty much take the AOSP, the Android open source version, and compile your own version to make apps. If you're in that situation, that's what you do. Because otherwise, and also you need someone to be able to vet all the portions. And so it's a trade-off between vetting all of your software and trusting the provider to some extent. Are there any more questions about in general malware or Android or anything else? Sorry. Okay, thank you all very much.